Yes, hello friends. How are you? I do hope you're good wherever you are. I'm also doing fine here. Welcome back again to the channel. We speak of engineering, construction, architecture, and surveying. Today I thought of doing some bits of slab design. And I want to take us through slab design using spreadsheets. The Excel spreadsheets. Excel spreadsheets are just like softwares, which are already built, which can assist in the design of different elements, structural elements. For this case, I want to just focus on the design of a two-way slab. I do hope you understand the difference between one-way and a two-way slab, and therefore I just want to move directly to the design bit of it. So it's quite straightforward, if you can follow with me. Quite straightforward. You even have the instructions. If you look at this portion here, we have instructions which you can follow actually. Enter data in blue cells only. So actually only where we have the blue cells, that is where we're going to put our data. And red messages indicate entry errors, then simply reinforce sections only. So just to move to it, assume you have a slab which is a two-way slab, and you want a quick way of designing it, right? This is not a substitute for understanding the design principles. I would really recommend that you first of all understand the design principles, and then of course Excel will really help you to speed up the process of design. But the moment you don't have the design principles, that means you're going to make an error, and always garbage in, garbage out, right? So make sure that you're good with the basics so that you can use Excel. Actually, it is so powerful in designing structural elements. Well, so the first thing you provide, you have to know the dimensions of your slab. Like in this case, we have the short span here. We can do a short span of 3 meters. We can just do 3 meters, and then we can do a long span of maybe 4 meters for that case. Then H is the depth of your slab. What depth do you really want to use? This one will depend with your design code. Different design codes recommends different. The minimum depth of the slab you can have for different purposes. And also you can come to Excel after you've done some kind of preliminary design, and so you know roughly what depth you want, and also the usage of the structure. Because maybe if we have vehicles parking in this slab, then that means we'll have a thicker slab. That case, so let us just go with 150 for this case. Top cover, cover to reinforcement, cover to reinforcement. I hope we are all understanding this one. Just 20 for slabs, that is okay. Then can also go to loadings now. Well, Excel will automatically calculate the self-weight of the slab, depending on the dimensions you provided here. Excel will go ahead and calculate the self-weight of the slab, because we also provide the density of concrete. Maybe just before I go to loadings, I can go through this section here so that we understand how the self-weight is coming up. This is the compressive strength. The compressive strength of our concrete. The concrete we want to use. You can use 25, you can use 30. That depends on the design, right? For this case, let us just use 25. This is the strength of steel, the reinforcement steel. 500. That is okay. Steel class A. Then we also have the density of concrete, 24. That can be prescribed by a code, but using 24 for this case, right? For normal weight concrete. Then these are the material the material safety factors. For concrete it is 1.5, and then for steel it is 1.15 for steel. That is the but again, that depends with the code you're using, so always make sure that you're guided by the code, so that you don't make mistakes. Then another section which we need to consider maybe is the edge conditions. When your slab is simply supported in both edges, in all the edges, that means the bending action, it will just carry that bending by the span. There will be no hogging at the edges. So you have to really be keen about this, because if you say it is continuous, for example, we say that edge one is here. If you say that edge 1 is continuous, then you can see what is happening. That means this slab is continuing to this direction. That means we will have hogging moments at this point. If it is simply supported, if it is continuous, discontinuous, you can specify that here for different cases. For this case, let me make maybe edge 1 and edge 3 continuous. Let me make them continuous. Then edge 2 and edge 4 discontinuous, just for the purposes of this design here. Well, let me now move to loading. Like I said previously, self-weight is calculated automatically by the Excel, right? So depending on the dimensions you have there, the self-weight will be calculated. For example, I just want you to look at the self-weight. I want to interfere with the thickness so that we see what is happening to self-weight. So if we use a 175 millimeters thick slab, the self-weight is coming to 4.2 kilonewtons per square meter. Well, let us just use our 150, and then the self-weight is going to be 3.6. Then the extra dead load. Extra dead load means this is from usage. Is it a residential? Is it a commercial? I mean, what is that slab carrying? That is the extra dead load. That will depend, with different slabs. So what is the extra dead load your slab is carrying? You have to calculate that load and put it here. This is not constant, it differs maybe in every slab, right? So your slab, the extra dead load in my slab could be different from the extra dead load in your slab. So make sure you have the correct extra dead load from your calculations, and of course after that the Excel will calculate the total dead load. It will simply add the self-weight plus the extra dead load, then you will have the total dead load there. The next thing is the imposed, the imposed load. This one you'll get guidance from the code, right? The guidance from the code. Depending on the usage of that slab, you can get the required, the imposed loads which you should be using to design that specific slab, right? And from there, Excel will get the ultimate load. Ultimate load simply multiplying the imposed loads with the factor of safety for the loads, and also the dead loads with the factor of safety. This one for this design reference is made to the BS, the British standards, that is BS 8110, Part 1, and the safety factors provided for the live loads is 1.6, and for the dead loads is 1.4. So if you take that and you do your calculations here, you'll arrive to a design load of 10.24. Yeah. Then from there, the moment you specify your information there, Excel will do the rest of the work, right? And you can come down here and see what Excel has done. Excel will calculate for you the moment, the maximum moment in different edges, you know. Like if you can see here, our edge 2 was discontinuous, so Excel doesn't calculate the hogging moments there. We have edge 3 here, which is continuous. Excel calculated the hogging moments, and also edge 1, Excel also calculated the hogging moments. And then we have, these are the span moments, right? The moments at the spans, you know, the shorter direction and the longer direction. We have the shorter span, we have moments there 4, then the longer span moments here. From this analysis, actually, you can take these loads and do your hand calculations, so that you compare your steel from the one which Excel is showing, you know. And actually, you can also just do the analysis by hand and see whether you're getting the same forces as the ones which Excel is showing. It's always good to have the basics, so that you can always interrogate the output which the software is giving you, because if you cannot interrogate the output, then that means you can never know when you've done a mistake, right? So it's very key. It's very key to be able to interrogate what the software has given you. This is the effective depth. D is the effective depth. Yeah. So the formulas which are specified for calculating the effective depth, that will depend with the code you're using, and also the case. After that, we also have the labrum and area of steel required, you know. So from the moments we have here, Excel will calculate for you the area of steel required, right? Area of steel required, and it will show you here. Let's take, for example, this is the short span. Excel is saying that the area of steel required is 77 square millimeters per meter, right? And the minimum, you know, the minimum steel required by the code is 195, you know. So you have the area of steel calculated, and also the minimum, right? Always provide the minimum required by the code. You don't want to go below what is specified by the code, right? Because these values are specified from rigorous studies, you know, and so there is a reason for that. So even if you get a lesser area of steel, make sure that you have the maximum. I mean the minimum area of steel. And so from here you can see what Excel is saying, that simply provide for the short span, provide 8 at 250, that is bottom one, right? And in the long span also provide 8 at 250, you know. And along the edges, edge 1 also provide 8 at 250. Actually here we just have 8 at 250. This one is the diameter of the bar, you know. So you can decide to use a bar diameter of 10 if that is what you have on site, but then this will give you 10s at 400. But make sure you just don't pass the maximum spacing which the code provides for the bars and slabs, right? Just make sure you don't provide bars at extreme spacings. You know, you have to check what the code recommends to be the maximum spacing of bars. So basically that is it. That is actually the design, and so this part, there is also deflection. Excel checks for the deflection, which you can confirm with your calculations, the hand calculations. You know, we have the actual span to depth ratios. You know, you can confirm from the allowable span to depth ratios, and make sure that it is within the permissible limits. It also calculates torsion steel. You know, in case we require torsion steel, you know, Excel will also calculate that. And then also the support reactions, you know, you can always go and study this deeper enough. For the purpose of this video, I just have to stop here, and I think we'll be doing more videos about this in the coming weeks or days. So if you feel that it is really helpful to you, please support the channel by subscribing and hitting the like button, right? And also make sure you share with your friends, right? I think I'd like to stop there, but maybe just before I stop, you can always check the last verdict of Excel at the bottom here, whether the span to width ratio, you check whether all the checks which you want to do, are they okay, so here you can check on this one is the shorter span compared to the longer span. This is the bar cover. Is it okay? Have you provided the minimum requirement? This one is singly reinforced. Minimum spacing of the bars, maximum spacing of the bars. Are you within the limits? If they're okay, then most likely your design is good. Always have the basics so that you can do your hand calculations, so that you confirm with what the software is giving you. I think I'd like to stop here. If you have any questions, please write them down in the comment section, so that we'll just go through them and discuss together. Thank you so much. Stay safe. Bye.